Hello. Welcome to another Hoot live stream. Interested in learning the best way to manage clusters seamlessly across multi-clusters and even multi-clouds? KubeFed, what is their project? Maybe no more. In this episode, I'm going to be able to catch up Jun from Spectro Cloud so that I can learn everything about Kubernetes Cluster-API. I am so excited to learn more on this topic. So my name is Lin Sang. In case this is your first time, I'm the director of open source at solo.io. I'm also being a long-time contributor and founding maintainer of the Istio project. Jun, I am so excited you are here today. Can you introduce yourself to our audience?
Yeah, sure. Thanks, Lim, for having me here. My name is Jun Zhou. I'm the Director of Engineering and also the founding Chief Architect at Spectro Cloud. Before Spectro Cloud, actually, I was in a previous startup called Clicker Technologies, which was also co-founded by our current CEO, Tenrui Fu. And there we were doing also multi-cloud management for the application workload. And at Spectro Cloud, we are kind of doing the similar thing, whether it's right now we are doing all the applications management within Kubernetes. So initially we were doing virtual machine-based workload management, and now we are managing the Kubernetes clusters as well as all the applications running within the Kubernetes clusters. So in my last couple of years, I had the chance to work with multiple new container technology project. Initially was Docker Swarm, and we were building something in 2016 timeframe, and we were looking for something to manage the Docker containers, and Docker Swarm was the solution we have chosen at the time. Then later on, a couple of years later, when we start a new one, when we choose Kubernetes, because Kubernetes already win the battle. So along the way, I have done like a couple of different projects using Kubernetes, and we do know the ins and outs of the Kubernetes cluster management issues and the challenges and the opportunities right there. And then in 2019, we started a Spectro Cloud, and we help our customers to manage their Kubernetes clusters, either it's in public cloud or private cloud. And we help them manage in a very consistent way, whether so all the full stack from the bottom layer to the top layer, we help them to manage all the across many different cloud and different clusters. Yeah, that's pretty much my experience and what we do here at the Spectro Cloud. Yeah.
That's awesome. Are you also a contributor to the cluster API SIG?
Yes. So when we started the Spectro Cloud in mid of 2019, we joined the Cluster API project from day zero, actually. Then at that time, actually, the Cluster API was not that mature. We had an internal kind of a long, 1 month long debating whether we want to join the community or we want to build something of our own to manage the Kubernetes cluster. Eventually, we make the decision to join the community to help the community, grow better. At the same time, we can also take all the great work that the community has done. And like after 2 or 3 years, when we look back, we think that this was the correct decision. We joined the community, make it better. We contributed a lot of new stuff into the community. Of course, we took all the great stuff that community has done. And right now, Cluster API was it is kind of the de facto tooling to manage the Kubernetes clusters if you are not going to directly use the cloud and manage the services like EKS or GKE, right? Other than that, Cluster API is kind of a de facto tooling. Many of the solutions out there are actually built on top of the Cluster API. To name a few, like some of the big names, like a Google Cloud Anthos. I think many of you should already heard of that. And also Red Hat OpenShift also, and also like a VMware Tanzu, right? Also the toolings they build on top of Kubernetes and built on top of cluster, sorry. And we are glad that we are also one, big contributor to the open source project. Yeah.
That's awesome. Okay, let's get to the news before we start interview, June. So the first thing I want to talk about is Buoyant aligns fully managed Linkd with Buoyant Cloud. This is pretty interesting. Well, Buoyant is really attempting to, take the management away from the users and be able to automate everything, most of everything for the users. The next news is Isavalan published next generation mutual authentication with Cilium service mesh. This blog has been really confusing. Probably one of the most confusing blog I read most recently for the past few months is what's really interesting from an Istio perspective was we were reading like the data coming out of the blog. Well, it has performance numbers of how Istio performs regarding latency, right? How Cilium performs. And our chief architect Yuval actually tried the data, and we couldn't come to anything closer to the data published. We've been also wondering, are we trying to compare layer 4 to layer 7? So the data is really misleading. Our buddy, our friend at Google, Louis Ryan, who is a principal engineer in Google, also spoke up with his voice, right? Uncontrolled L7 config in a multi-tenant proxy is an outage and noise-enabled factory. So interesting perspective, definite encourage folks to get all different perspective on this. Let's see. That is the news for this week. Regarding the Hood, next week we are so excited. We're going to have KubeCon Europe in Valencia. So I will be there in person. I'm hopefully to meet many of you there in person. So we will not have a Hood next week, but we will have something exciting for you the week after. So stay tuned on the agenda for that. With that, I'm going to start pick brains of June. What is the persona targeted for Cluster API?
Yeah, so that's a good question. I think that's the first question you already will ask when you go into the one of the open source project. So Cluster API is to manage the Kubernetes lifecycle of the underlying cluster itself. I know in this broadcast, most of the time the topic was around like upper layer, right? The service mesh layer or application layer. Those kind of already running within a Kubernetes cluster, which is already managed by some other product. So Cluster API is to manage this underlying Kubernetes cluster. So technically, for anyone who want to set up a Kubernetes cluster and try it out, either it's a developer or a DevOps team, they can use the Cluster API. But having said that, if you're just trying to have a local cluster just for some very simple dev testing,
right? There are which I would use kind, right?
Yeah, exactly. Like a kind or Minikube, many solutions out there for you to have a local cluster very easily to bring up. So you don't have to use a Cluster API in that sense. But if you have some like a production workload, and if you have the workload that you want to manage it within maybe different cloud, right? Public cloud or private cloud or even bare metal, then if in the cloud you do not want to use the cloud managed service for whatever reason, if you do not directly use EKS or GKE or AKS, then I think a Cluster API will be the best choice for you. The Cluster API is designed in such a way that could easily help you to manage your workload across many different environments and across many different clusters. Yeah.
Okay, so my next question is why do users need to pay attention to Cluster API? Sounds like the you try to answer that question already, which is if you have a Kubernetes cluster that you need to spin up across maybe different clouds, different environments, the cluster API provides this simple, consistent experience that's declarative for you. Is that anything
exactly.
you want to add? Okay.
Exactly. Yeah. I think for a specific open source project, first of all, the cluster API itself is one of the Kubernetes sub project. So it's under the umbrella of Kubernetes, and kind of guarantee that it will have the support from the community, right? Not some one person hobby project. It's supported by the whole community. And actually, right now the community is very active. I just took a look a couple of days back when I prepared this. Like there are more than 400 contributors.
Wow,
I remember
that's a
2 years.
lot.
Yeah, it's a lot. So 2 years ago, when I was preparing another kind of article, well, actually 1.5 years ago, I checked the contributor. At that time, it's around 200. So like right now it's more than 400
Yeah,
contributors. So
amazing growth.
yeah. So the community is very active. That means there will be new features coming in. There were continuous bug fixes or security patches along the way. So that's the first thing, right? The project is going on very healthy. Then
That's great.
in Spectro, with regarding the actual product itself, like I mentioned, the Cluster API was already used by many of the bigger players out there, like Google Anthos, VMware, Red Hat, and there are many couple of other startups also using Cluster API. So it is already the de facto tooling to manage the applications and manage the Kubernetes cluster, like I mentioned. It's using a very declarative way to doing that, so which will save the users many manual steps. You don't have to do many manual steps to provision the cluster. It's very consistent. It's very easy, and of course, like I mentioned, it's to support all the different cloud. So whether you have either one single cloud or many different hybrid cloud, it could make it work for you. And
can I ask you if I'm saying my Kubernetes is compliant with Kubernetes compliance test? Does that means it already implement the cluster API?
I think
Or not
maybe
necessarily?
it's not necessarily. So if I understand your question correctly, you are saying that Kubernetes cluster itself is like a CNCF conformant, right? The API from API perspective.
Yeah.
So that is just from the API of the Kubernetes to the end user, like to the application developers.
I see.
But to deploy a cluster with that conformant, there are many different ways, and Cluster API is one of the way to help you do that.
Okay, got it. That makes sense. Can you explain how Cluster API work at a high level?
Yeah, sure. Yeah. So this is kind of a high level how Cluster API works. Like I mentioned, like Cluster API is using a declarative API model. Basically, it's trying to utilize Kubernetes to manage Kubernetes itself. So before Cluster API, there are many other tools already exist. And all of these tools, they either using like a command line or any other format. They do not use Kubernetes to manage Kubernetes. And Cluster API was the first one trying to utilize, because Kubernetes itself already have most of the control logic built in, like have the HA control plane, have all the grid API extensibility. So Cluster API, how does that work? It kind of define a couple of different CRDs, and a CRD with regard to customer resource definition. And you just define what you want for the cluster. Like there are a bunch of CRD, like cluster CRD, machine CRD, and some higher level CRDs like a control plane and the machine deployment. So the control plane CRD is trying to manage the control plane node, and the machine deployment CRD is to manage the worker node. So with the CRD, you just define, for example, like what is the cluster version, and how many control plane nodes, how many worker nodes, and then you'll have a management cluster, and this management cluster will have the CRDs already defined, and then there are a bunch of controllers running within the management cluster. Then we're just trying to go ahead and create the virtual machines and create the control plane, create the like a machine deployment, and then trying to bring up this workload cluster inside all the different cloud environment.
Yeah.
So this is the
Okay. Sorry. Go ahead.
Yeah. So
are you wrapping up on this topic?
Yeah, another slide I want to just quickly show like internally how this works, right? So this, so from this perspective, though the infra provider, the bootstrap provider, all the different providers, in the end they will take some like a definition from the CRDs, like the cluster definition, control plane and worker definition. It will generate some like a kubeadmin config. So kubeadmin is one of the default like a management tools from the Kubernetes community as well. It is trying to do all the cluster bootstrapping. Once the kubeadmin config is done, then the infra provider, like the infra provider means like per cloud, like either it's Amazon or VMware or Google, that they will have their own provider to talk into their own cloud APIs. So I will take the machine spec, like how many CPU and memory, and then take the kubeadmin config. In the end, it would create either a virtual machine or a bare metal machine. And from within the cloud init will run like a kubeadmin init or the join to bring up this whole cluster. So this is the high level, like how cluster API works.
Yeah, that makes sense. So is Cluster API, what if I deploy my cluster out there? Do you do any lifecycle management of my cluster? I mean, certainly, Kubernetes has so many patches, there are security fixes. Does Cluster API help the admin take care of all that?
Yes. So that's a great question. To manage the Kubernetes cluster itself, I think one of the biggest challenge is there are so many new releases coming out, right? Either it's a new feature release or the security patch. There's so many releases out there we're going out. So the challenge is how do you upgrade your Kubernetes cluster? The challenge is not in the day one, it's actually in day two. Like how do you upgrade? And Cluster API will actually help you do that. Because of this declarative API model, right? When you try to do the cluster upgrade, the only thing you need to do is tell the controllers, okay, I want to change the version from, for example, 1.21 to 1.22. That's the only thing you change. You tell the controller, you change your desired cluster spec, like the version will be changed to 1.21 to 1.22. That's it. Then the controller will, in the end, help trying to rolling upgrade all your worker nodes and the control plane nodes within the cluster, and eventually bring up the cluster into a newer version. So this declarative model is kind of not very much difference between the initial provision and the day two management. You just tell, okay, this is my expected desired state, and then the controller will try to do that for you.
So what about patch release? Do you also have to specify this is the exact patch release I need to be on?
Yes. So from the cluster API perspective, you need to tell the controller, like if there's a new patch, like a 1.21 to 1.21.1 to 1.21.2, again, you specify the patch version, and then like cluster API will try to bring up the new patch version as well.
Okay. Yes, I guess it works similarly as the Istio operator API, which a while users just use to tell the system, the control plane, what are the version of Istio they want to install. The only difference I would say is Kubernetes upgrades has been really boring, right? It works. Well, Istio upgrade is more exciting, it needs sometimes a handshaking. All right, that's exciting. So the next question I want to ask you is, how are you leveraging Cluster API at Spectro Cloud? I assume it's for multi-clouds across different providers.
Yeah, so like I mentioned, we joined the Cluster API community when we started the Spectro Cloud, and we leverage all the great work from the community, and at the same time we contribute back. So the underlying platform of Spectro Cloud is using the Cluster API to do all the cluster management. But Cluster API itself right now, as of today, still lacking a couple of capabilities. For example, the uh, application management. So the Kubernetes cluster itself, in the end, need to serve the application, right? We run a Kubernetes cluster not for the cluster itself. We want to run some workloads within the cluster. So Spectro Cloud uses Cluster API to provision the underlying Kubernetes cluster, and then on top of that, we help our customers to manage their applications as well. So that is one aspect. The second aspect is obviously we like manage all the clusters within all the different cloud. So we provide a very consistent, like a single pane of glass for our customers to manage all their applications and clusters within all the different cloud, whether it's public, private, or bare metal. We have recently also released the like a padded metal, real metal platform. So we are also going into the edge locations to manage the Kubernetes cluster on the edge for all the different use cases at the edge. So in the end, I think the Spectro Cloud help the customers to manage a fleet of clusters across all the environment, and the underlying building block is Cluster API, and we build on top of that. Yeah.
Yeah, I've seen your UI. It's Alex Lay from Solo did a demo recently using Spectro Cloud and Glue Mesh to stand up a cluster, to install Glue Mesh. I've seen your demo. The UI is pretty sleek. Yeah.
Yeah, thanks.
So, what's your perspective? How do you see service mesh fits in the puzzle here, from a Spectral Cloud perspective, with building solution on top of Kubernetes, and also you're providing solution on top of Cluster API at the app layer, right? So, where do you see service mesh fitting?
This is a good question. I think Spectro Cloud and Solo have been working closely together in the last couple of months with one of the bigger customers. We all, one of the shared customers. And I think one thing that we do see from the experience that we work with our customer is, although there are many different vendors out there for the different challenges within the Kubernetes clusters, but when the customer they trying to provide the Kubernetes service to zero end user, for example, for IT department within a big enterprise, right? When they try to provide the Kubernetes to zero end user, they took the Kubernetes cluster as a whole platform. That means not only the Kubernetes cluster underlying, but also all the add-ons or the system solutions running within the Kubernetes cluster, which definitely will be including service mesh as one of the very critical component. So when you took this whole thing as the whole platform as one thing to manage, there is really not that much opportunity or solution out there to help you do that. And Spectral Cloud has provided a very unique way to let the users or customers define everything within a single blueprint, or we call a cluster profile, right? The cluster profile will contain the what is the operating system, what is the Kubernetes version, what is the networking storage, and also what is the service mesh layer, what is the logging monitoring, basically everything that they will need to run it within the Kubernetes cluster can be defined within this cluster profile. And service mesh is obviously kind of a bridging the gap between the underlying Kubernetes and the application, because it's a very critical component for the application, right? So using this unique coherent way to define what's needed within cluster, it's very easy for the customer to manage multiple different clusters very consistently. And for a single cluster. So that is the one perspective, right? So Spectro Cloud will help Solo and other like a different component service mesh layer to very easily to manage it within a single Kubernetes cluster. On the second aspect is if we think about the application development, at least to my perspective, right now the most of the application running within a Kubernetes boundary. That means it runs within one single Kubernetes cluster. And we do see the requirement to span across multiple different Kubernetes cluster, and service mesh is helping application to do that. So when you have multiple different Kubernetes clusters together with your application requirement to span, together with your service mesh layer need to span across different cloud. So there really need one kind of a single platform for you to manage all the different Kubernetes together, right? All the clusters together. And we do think that Spectro Cloud can fit in, working with the service mesh layer to really provide a very consistent way for the application to consume the underlying infrastructure. So those are
Yeah, at Solo, we are very excited to work with Spectro Cloud to solve this application network challenges, not just for single cluster. Certainly, we want to solve it for single cluster too, but also for clusters, multiple cluster that span multiple clouds, and be able to leverage service mesh to provide that zero trusted network, right, for the application to be able to provide the defense in depth, right, at every single hop that we can trust, and we don't allow any unnecessary access. By the way, hi, Oma. I see a really nice comment from you. Welcome, Oma. Spectro Cloud seems amazing and filling a great gap. So thank you for that comment. With that, I think I'm looking forward to the demo. Can you show us a demo of Cluster API?
Sure. Let me share my screen. Let me know you can see my terminal. Cool. So the cluster API, like I mentioned, right, the way it works is you have a management cluster, and then from the management cluster, you can create and manage all the workload cluster. So here I have a simple kind cluster. So Kinda, if you do not know that yet, so Kinda is one of the tools to help you create a Kubernetes cluster within Docker itself. It's called Kubernetes in Docker. I have just the Docker installed in my local laptop, and I create the Kinda cluster within this kind of tooling. So within this kind, I'm using it as a management cluster. And from there, I'm creating two workload clusters. Like one cluster I call it like AWS, and the other one is the EKS. So internally, Cluster API actually supported two types of the clusters. One is the virtual machine based cluster. That means the Cluster API will go ahead and create the virtual machines. Either it's in public cloud and or private cloud. It will create the virtual machines and then go into in the virtual machine to do the bootstrapping and then join all the worker like virtual machines or bare metal machine into a bigger Kubernetes cluster. So the second type of cluster is supported the management service. That means for AKS, EKS, and not GKE yet, but these two management Kubernetes service, it can also support directly from Cluster API as well. And in this demo, I'm kind of have two clusters running within Amazon. This AWS one is the virtual machine based one, and the EKS one is the management service based one. Because of like the creating within AWS, when we try to create the cluster, if you know, you need to provision the VPC first, and the provision VPC kind of taken a long time. So I initially like launched this cluster like beforehand, and I can quickly show what are the CRDs, what are the controllers that we have talked about. So if we take a take a look at all the pod running within my kind of cluster. So we have a CAPI controller. This will be the per cloud provider controller. So this one will be talking to AWS for all the EC2 API or EKS API. We have a bunch of other controller like the Bootstrap controller will be able to generate the kubeadmin config. And this control plane controller will be managing the control plane like the etcd rolling upgrade, etcd membership management. And then this CAPI controller will be managing like the actual machines or machine deployment and all those. So usually you will have like a per cloud controller inside its own namespace. And then the CAPI ones will be common for all the different cloud. So this is the way, like a kind of a plugin architecture, the Cluster-API will be able to support many of the different cloud. Let's see if we have one of the construct one of the CRD is called a machine. So each one of the machine will correspond to a virtual machine in the cloud, and eventually will be corresponded to a Kubernetes node within the cluster. So for my demo AWS cluster, you can see I have 3 machines. I have a 1 control plane machine. I have like 2 workers. The 2 workers, it's kind of defined with 1 machine deployment. With this machine definition, I have another layer of AWS machine. So the AWS machine, again, it's like a per cloud. This is how it is supported on like multiple different cloud from the CRD perspective. So the machine object will be common for all the different cloud. Eventually, the machine object will have kind of a relationship to the per cloud machine object. In this case, it's called AWS machine object. And then we have this KCP object. So the KCP means the kubeadmin control plane. And this one, you can see have what is the version. This one will mainly define your cluster version. So all the control plane component like API server, controller manager running within the CP node will have this specific version. And you can define like a 1 replica, 1 control plane node or multiple control plane node. In this case, the demo, we have a 1 replica. Another CRD is the machine CRD, the machine deployment CRD. In this case, the machine deployment, it is similar like the application, right? If you think about the pod and like a deployment for the application, for the containers. So the machine deployment and the machine kind of following the same pattern so it's
can you do a -o YAML on this config so we can see what's in there?
Sure.
Thank you.
So the machine deployment, sorry, this is a little bit, so this is the metadata. This will be the spec, right? The machine deployment, you can see what are the replica numbers. And the selector, very similar to the deployment, see like the native deployment API definition. What are the selector will be matching all the machines, and then it will contain a template. So the template will contain, first of all, what is the kubeadmin config template? This guy will provide the internal kubeadmin configuration, and then it will contain the reference to the infrastructure, like the AWS machine template. The AWS machine template will contain like what is the CPU memory, what is the instance type, what is the region, zone, and all the information. And of course, this the version of the machine deployment itself. So this is the machine deployment. Eventually, like when we just need to create all the CRD within this management, like a Kubernetes cluster, and then the controller will go ahead and create the cluster itself. Once the control is done, this is one of the EKS cluster. Sorry, we can show the like AWS cluster first. So if we check the node here, check the node here, we can see this is the actual like the target workload cluster already provisioned by the controllers. We can say that it have 1 control plane. We have like a 2 worker nodes. So all the information will be available, kind of already captured within this management cluster. So from the control plane, from the target workload cluster perspective, it doesn't know anything about the management cluster. But from the management cluster, you can do all the like a scale up and a scale down. We can quickly try if let me open this. If we want to, for example, do a scale up, right? If we want to now it's a 2 replica. Let's see, we want to create a new node. Let's see how it works. We just need to change the replica from 2 to 3, okay? And we do the save. We can see the phase is trying to scaling up, and there's one unavailable replica. That means it is trying to create a new one. So if we check the machine object right now, there are 2 of them right now for the machine deployment. I think there will be a new one created pretty much soon, the new machine deployment.
So that's another new cluster that's being provisioned?
This is a new
it's
node
a new
within,
node. Okay.
within the cluster. So if you want to create a new cluster, so I can show you what I provided to create this cluster. Right, this is just the YAML file we generated to create the cluster. The cluster contains what is the control plane reference, and then the infrastructure cluster. This is the very top level, like kind of umbrella. Doesn't contain much like a logic. But in the end, your app, like AWS cluster, will contain what is the region, what is the asset keys, or the other cluster level definition. Control plane, Kubernetes control plane will manage the control plane, like the etcd membership, how many replicas for the control plane. And these are captured the Kubernetes configuration internally when you bootstrap the cluster. And what is how many replica you need, and what is the version of the control plane. In the end, it will contain a template reference, like an AWS machine template. So the AWS machine template will specify like what is the instance type, what is the image, or any other things that specifically to the cloud itself.
So question, the versions of the control plane, does that also have to match the version of the Kubernetes that's going to be stand up?
That's a great question. So usually the Kubernetes version kind of refers to the control plane version, right? If you're talking about what is the version of the Kubernetes cluster, usually it refers to the control plane version, which is running within the cluster. So from that sense, the control plane version should match the cluster version. But the worker node doesn't have to be exactly the same, especially during the rolling upgrade, right? You might want to upgrade the one worker pool first, keep the other one to stay if there are any issue, things like that. So there's a version like a screw management between the different versions, but it doesn't have to be exactly the same for the workers and the control plane.
So there is a way you can specify the workers version as well in addition to the control plane? Okay, makes sense.
So this machine deployment is for all the workers, right? The machine deployment, similarly, you will specify like how many replicas. And then for each of the replica, similarly have 2 reference, one same to the control plane, have this Kubernetes, and also have the machine template. And also you specify the version here. So this version will specify like the kubelet, what is the kubelet version running within the worker node, and this kubelet will be talking to the control plane.
Okay, very cool. Do you want to check if your other node come up now?
Yeah, let's see. We can see now there are 3 replicas right now. Still there's one unavailable, means it is still trying to bring it up, join the cluster. Let's see the machine. Yeah, this is the machine object already created, and is I believe there should be another AWS machine internally also trying to spin up. Yeah, the cloud is still trying to create this new machine, and will
I forgot. I forgot it's the AWS cloud. It's actually taking a while. Sometimes when you use Google Cloud, it's just a lot faster.
Yes, yes.
Yeah,
Yeah.
got you. But at least the resource is there, right?
Yeah.
So that the controller can listen to the request and spin the VM, and
Yeah.
for the Kubernetes work exactly as what you ask them to do.
Yes, yes, exactly. I can quickly show another another cloud, like the EKS based cluster. So that one is a little bit different. So that one we do not manage the control plane because the EKS manage the control plane itself, and that we use a kind of AWS manage the control plane. So this manage the control plane, we do not specify like the how many replica, what is the CPU memory, and all the information. So this manual control plane will be corresponding to the EKS configuration itself. And then for the worker node, again, we do not specify like the machine deployment. We are using the AWS management machine pool, what called AWS managed machine pool. So the machine pool kind of similar to the machine deployment. You specify the replica numbers. You specify like what is the AMI, what is the subnet and the like the node group information and all those. So the difference is that we do not manage the machine individually, like we do if it's the virtual machine based cluster, right? We manage each individual machine specifically. In this case, we only manage the pool level, like within the pool, it is up to EKS to kind of do the auto scaling, do the like node management and all those.
Interesting. And I assume the similar resources, maybe with small configuration tweaks, you could take them to deploy AWS and also not only just AWS, Azure and Google Cloud.
Yes, yes. So the tooling cluster API have a tooling called a cluster cuddle. So cluster cuddle is I can show you my script. Very easy to generate the cluster definition. So this is how I generated the two definition using cluster cuddle, right? So for each different cloud, you are just using cluster cuddle, generate the cluster, give it a name, provided the flavor kind of what is the infrastructure you want to use. For EKS, it is a managed machine pool. For the like a virtual machine based, you just provided the infrastructure as AWS, and then you give it what is the version you want, how many numbers, how many replicas you have. These are the two like very simple lines I use to generate the data to YAML files, and then directly you apply the YAML file, and the controller will just trying to spin up. Similarly, if you want to create the cluster for other clouds, like you just need to change this infrastructure, either it's a GCP or VMware or anything else. It's very easy for you to do that.
Yeah, so that's really cool because you don't have to learn each individual cloud provider's command, right? Or even install them. So now I guess my next question is, assuming I have this root demo eks.yaml or aws.yaml generated, do I just use kubectl to apply it? Or
Exactly.
I think okay.
Exactly. Yeah. Yeah. So after you
That's
generate the
awesome.
YAML file, yeah, just use the kubectl apply.
Okay.
But of course, beforehand, there's the one kind of innate. So the initialization, this is the one like the cluster cuddle init will help you install all the CRDs, help you install all the controllers within your management cluster. And again, you don't need to worry about like how do I install, where do I pull the CRDs, where do I pull all the port definitions for my controllers. This cluster cuddle init will help you do all these everything. So in the end, it's just two commands. One is cluster cuddle init, and then cluster cuddle generate, and well, the third one is just the kubectl apply. So they're pretty easy for the process.
That's awesome. I feel this is the new way I want to use to provision, Kubernetes cluster in different cloud, because the API is just the same. The
Yeah,
commands, I can just specify different infrastructure. So thank you for
yeah.
teaching me that tip and the cluster API. Is there anything else you'd like to share before we wrap up?
That's pretty much it for the demo. Yeah.
Awesome. This has been really interesting. I want to take a moment to thank you, Jun. We really appreciate you sharing your knowledge. And we also get to learn a little bit about Spectro Cloud and what Solo and Spectro Cloud is doing together. How do folks reach out to you if they have any questions?
You can reach out to me through LinkedIn. If you search me like a Jun Zhou from Spectro Cloud, you should be able to see me. And also you can also reach out to me email as well. The email is also like my first name, Jun, at spectrocloud.com. Yeah.
Awesome. And I apologize, Faye. I just saw your question. Thank you so much for being at the hoot of almost every single session we have. We really appreciate audience like you. So Faye is asking, how many providers do you have? I assume all public clouds, including big 3S in the US, along with Alibaba?
Yes,
Great
yes. So
question.
yeah, great question. All the like public and private cloud, if you can think of, I would say I'm pretty confident that there will be a provider already available. Like all the provider, the cloud provider within US, either the public or private, and also within China, like Alibaba, Tencent, even Baidu, and also some
Oh,
of the edge
wow.
providers, they all have a provider over there.
That's awesome. I feel like a cluster API is very mature. It's really widely adopted.
Yeah.
Yeah, thank you, Faye, for that question. All right, thank you so much, June. And I hope, folks, that you guys find this interesting. And if you do, give us a thumbs up and also subscribe to our channel so you don't miss any of our future Hoot episode. And if you have specific topic you want to see or special guest you want us to invite, please let us know. Comment on the side or below whenever this gets published. And I'm going to go to KubeCon, so hope to see you, some of you next week. If not, I'll see you the Tuesday after KubeCon. Thank you so much. Bye now.
Thank you. Thank you. Bye.